It's been surprising, pleasantly surprising, the cost curve as it's come down. I think a gentleman from Micron just before lunch was saying maybe folks like Dell are too hard on him, but we appreciate your support. And we've been able to bring SSD into some of these lower cost devices at a capacity that's fairly constrained, frankly, but is appropriate to the product space. It's been a surprise how quickly that has been catching on in the energy in that space. Secondly, technology. So I think a year ago there was a lot of concern that maybe the reliability characteristics of MLC would be problematic. And what we've seen is that in general, the consumers or customers that are adopting flash SSDs seem to be comfortable with MLCs, seem to like the larger capacity, the better price per capacity that MLC can bring. So faster than expected MLC adoption in PCs. And then lastly, the value. We're seeing there are some drives out there that have 10,000 RPM equivalent performance already in notebooks. And I'll talk to performance a little bit more in the enterprise space as well. But there were some surprises. A year of great progress. I think someone showed earlier this morning the Gartner hype cycle. I think that SSDs and flash in general still are getting a lot of hype. I would tend to agree with Gartner that it's probably over the peak and heading towards sorting out the reality. There's still some problems that need to be addressed, and those are the things that I wanted to talk to you about today. It's clear to us at Dell that there are benefits to flash and SSD in the enterprise space. And I've just listed some factors here. Embedded intelligence that comes along with flash, the controller associated with it, has some value proposition to it. Random I/O performance is one that people talk about a lot. Better power consumption characteristics. And by the way, I would make this point, unlike the notebook, where the hard drive is a relatively small percentage of the overall power in a notebook, in the enterprise, rotating media consumes quite a few watts, so can be significant, both inside a server and in storage dedicated devices. So power consumption is a pretty big thing in the data center today. And then lastly, storage density. First of all, in performance. Where we're at today, in general, most SSDs for the enterprise space kind of look like the left-hand bottom. The upper left-hand corner says RR for random reads, and then I've got random writes, and in the upper right-hand corner, I guess it is, and then the lower is streaming reads and streaming writes. So it's kind of the four quadrants of all reads or all writes, whether they're random or they're streaming. In general today, many SSDs kind of look like the left-hand column. They really have a great story for random reads, but not so great a story for the other three quadrants. Now, there are some drives that we've seen that are, would be characterized by the manufacturers as premium drives that look more like the right-hand side, where the streaming the random reads look fantastic. The other three quadrants look about, say, equal to or maybe slightly better than 15K RPM drives today. So some of those drives do exist. The message I want to give to you is that I think where this really starts to take off in the enterprise space is rather than just premium drives having the characteristics of the right-hand side, is when really the more mainstream SSDs for enterprise space look like the right-hand side. Not only for these four quadrants, but also the in-between cases, the real-world cases of mixed reads and writes, where in many cases when we test SSDs today, there's a pretty significant performance droop in the the 50-50 or non-100% case. If you get a mix of reads and writes, many drives have a droop scenario where they may actually look worse than a hard drive. And so these performance characteristics need to be addressed by the manufacturers, focused on the manufacturers, where in general, users see a kind of across the board equal to or better than performance relative to a hard disk. But if they have a random read heavy environment, they see huge upside. I think that's the real value proposition for SSDs and where we as a collective industry need to take the technology. There are numerous things going on in the industry today that are driving more randomness in I/O. And in fact, randomness in I/O, specifically random reads, feeds in perfectly to the technology that we're talking about today. So the factors that I've got on here, increasing CPU cores, of course, as you have multiple cores running their different contexts, that results in randomness in I/O as threads bounce between the cores. And share access to the I/O subsystem. On the upper right-hand quadrant, increasing use of virtualization. Again, you have virtual machines which are totally independent of each other, different contexts, different memory address space, different applications, resulting in very random nature access to I/O. In the bottom right-hand side, as we look at increasing SAN scalability, and by the way, I'll put a little plug in for the storage technology from Dell, iSCSI technology, which we think is huge going forward, and results in really highly scalable SAN systems. As you look at the scale of SAN growing, that means the ratio of initiators and targets is going way up. So again, resulting in more and more random I/O nature in the industry. So you put all of those things together and you say there's just increasing randomness in our IT infrastructure. It's a great fit for the technology. And oh, by the way, if you look in the lower left-hand quadrant, as buses continue to go up in speed, then you can start actually taking advantage of these highly parallel flash subsystems that can feed very high IOPS into the system. So it's a great fit, it's a great time. Technology is perfect for the need, and I think as long as we collectively really address the issues that I called out earlier around balanced performance and a strong reliability story, then I think it's timely for the enterprise. We need a naming convention for SSDs, and that point was made earlier this morning on the panel. I was glad to hear that one queued up. So as we were going through creating these slides, we got our marketing guys to look at it, and they said, so the example we use here is maybe you come up with a number with an X, like a multiplier, 2X and 10X and 66X and 300X. Our Dell marketing guys said, we hate that approach. So I can guarantee you, what I've got up here is not what it should be or what it will be, but the point is, the industry needs to come up with a naming convention that end users can understand, that tells them what the performance level and performance expectations for those SSDs will be. We've had the 7200, the 10K, the 15K RPM kind of metric for hard drives for a really long time. People can get that. We need some type of naming convention metric associated with SSDs to get appropriate tiering within the pricing and performance structure within the industry. 4 areas that I want to leave you with. One is there are some standards efforts that need to continue, need to get more emphasis. The NVMe HCI we think is very, very important. Extending technology for SMART into SSDs we think is very important. Focusing on balanced enterprise performance and bringing that balanced enterprise performance into really mainstream enterprise SSDs. Bringing reliability to enterprise SSDs that is equal to or better than, preferably better than, enterprise hard drives is a critical inflection point. And then lastly, we need some simplified positioning so that end users and buyers for data centers really understand how to compare apples to apples between different technology offerings in the marketplace.